Hello, good day. Our topic is about queuing theory, or some commonly known as waiting lines. So, by definition, queuing theory is the mathematical study of waiting lines, or queues. It is a branch of operations research because it results into managerial decisions relevant to optimizing a service. A queuing model is needed to solve various scenarios involved. By the way, it was pioneered by Agner Erlang in 1909. Okay, so example of a queuing model pattern that is commonly used is the MM1. So MM1 pattern. So M here is the arrival time, which is in a normal distribution, or sorry, a Poisson in distribution. Service time here, which is in exponential. So we have 1 denotes we have a single server, or the number of servers, which is 1, and then we have infinity. So it means we have infinity customers coming in the system, and then the service discipline is first come first serve. So ito yung usually ginagamit, no, sa basic introduction of queuing theory. So the relevant formulas for this pattern, we have symbols like lambda. It stands for arrival rate. Then we have the mu, which is service rate. And then we have the utilization rate, rho, which is in percentage also, when we want the percentage time. So the condition should be the mu should be greater than the arrival rate. And then the formula for utilization rate is lambda over mu. Okay. Other formulas which is relevant: P sub O, that the probability of the system is idle, or we have no customers in the system. Ito po yung mga formulas. P sub N, the probability that the system has n customers. So when we say we want to predict the probability to having 2 customers, we just put 2 here. Yan po yung dalawang formulas. Other formulas like L sub Q, it means the average number of people in Q. We have 2 formulas here. And then L sub S, average number of people in the system. So take note, to further explain what is the difference between a queue and a system. Say for example, ganito lang po, no? We have 4 numbers, number of people here, and then we have 1 being served, and this is the counter. So when we say queue, ito po yun, the waiting line. This is the queue. While when we say system, 4 plus the person being served, that is the system. Okay, the whole system. Okay, to continue, so we have WQ, stands for average time in the queue, we have two formulas. We have W sub S, or average time in the system. We have two formulas. Take note that this is in hours initially, or if you want, you convert it into minutes, no? So we have a problem here, sample problem, a simple problem for MM1 infinity first come first serve. Example pala nito, no, is when you notice in counters of fast food outlet, no, takeout counters, drive-through of a Jollibee or McDonald's outlet. Also, kung mapapansin nyo sa sa single toll gate scene in NLEX, no, or an ATM booth, etc. So let's say there's a given in lambda, no. So we have the arrival rate, we have 90 persons per hour, and then mu, we have 110 person per hour. So we are asked to find the rho, or the service utilization, the probability that the system has no customers, P sub O, the probability of having one customer, we have the L sub Q, which is the average number of people in queue, the average people in the system, the average time in the queue, and the average time in the system. Okay, first we will solve for rho. So rho lambda over mu, we have 90 over 110 is equals to 0.81. Means that average number of people is 0.81, or if we convert into a percentage, we have 81%. It is 81% that the counter is busy at that time. Okay. So next is we solve for P sub O, or probability that the system is idle or no customers. P sub O is 1 minus our answer minus rho. Meron tayong 0.19 or 19% of the time, 19% of the time that there's no customer. Okay, so ito is 81% busy, 19% idle. Next, we solve for P sub 1, or a probability of the system having one customer. For P sub n, or P sub 1, one customer, we have 0.19 times the rho, which is 0.81, raised to n, which is 1. We have 0.1539 or 15.39%. Next, we will solve for L sub Q. So average number of people in queue. L sub Q is 90 squared over 110 quantity 110 minus 90. So this is 90 squared is 81 over 2200. We have 3.68 people or persons. Okay, we solve for L sub S, or the average number of people in the system, we have yung L sub Q, which is 3.68, plus the row, which is 0.81. L sub S therefore is 4.49. No? So kung idodrawing yan, 3.68, maybe this is 4, and then this is, let's say this is 5. So yung nakapila in Q is 4, and then merong isang sineserve. So ganyan po yung itsura niya. Then now we solve for W sub Q, average time in the queue. So we have 3.68, no, divided by 90, or the lambda. We have 0.04, no, which is in hours. Okay, so if you want to convert that in minutes, just multiply it. 1 hour is to 1 minute. No, cancel, we will have, so para mas madaling tingnan, that is 2.4 minutes. No? Okay, lastly, for W sub S, which is 0.04, no, which is the W sub Q in hours, plus 1/110, which is the mu, then we get 0.049 hours, or equivalent to 0.05 hours. When we like to convert this into minutes, is it equivalent to 3 minutes. Okay, so ibig sabihin nito that the average time in the system, or the mean waiting time, is 3 minutes for the whole system. So that's it. Thank you very much for this basic tutorial for queuing theory, and hope you like it. Thank you very much, and God bless.